Right now, as you're watching this, 140 million miles away from Earth, something extraordinary is happening on Mars. Buried beneath layers of rust-colored dust and ancient rock lies evidence so shocking it's forcing scientists to completely rewrite the story of our solar system. For decades, Mars has been painted as the dead planet, a frozen, airless wasteland where nothing could possibly survive. But what if that entire narrative is wrong? What if Mars isn't the barren desert we've always believed it to be, but rather the graveyard of a world that once teemed with possibilities? In 2022, a Chinese rover no bigger than a golf cart made a discovery that sent shockwaves through NASA, ESA, and every major space agency on Earth. The data it collected was so unprecedented, so mind-bending, that it's forcing us to confront a terrifying possibility. Mars once had beaches, tides, and vast oceans that could have supported life for millions of years. This isn't science fiction. This is the most important planetary discovery of the 21st century, and it's being led not by America or Europe, but by China, a nation that has just announced its intention to send humans to Mars by 3.6 billion years ago. Mars was unrecognizable. Where today we see endless plains of red dust, there once stretched vast dark oceans. Where we now find only silence and emptiness. Waves once crashed against alien shorelines under a sky lit by two moons, Phobos and Deimos, dancing their eternal celestial ballet. But here's what makes this discovery so extraordinary. We're not talking about puddles or temporary lakes. We're talking about oceans that may have persisted for millions of years, long enough for life to not just emerge, but to evolve into complex ecosystems. Think about what that means. While Earth was still a young, violent world being constantly bombarded by asteroids, Mars may have been a blue planet with stable coastlines, river deltas, and all the ingredients necessary for life to flourish. For over 4 decades, this possibility has been the holy grail of planetary science. The Mars ocean theory has divided scientists into warring camps, sparked heated debates at conferences, and driven some of the most ambitious space missions in human history. Skeptics have dismissed the evidence as wishful thinking. Climate models couldn't explain how liquid water could exist on a planet receiving far less sunlight than Earth. The debate seemed destined to remain unsolved forever, until China decided to settle it once and for all. July 23, 2020. While the world was paralyzed by a global pandemic, something historic was happening at China's Wenchang Space Launch Center. The Long March 5 rocket, standing 57 meters tall and weighing 870 tons, was about to make China a major player in the most exclusive club in the solar system. Nations that have successfully operated rovers on Mars. Only one country had ever accomplished this feat, the United States. The Soviet Union had tried and failed. The Europeans had tried and failed. India had managed to orbit Mars, but never landed. Mars, it seemed, belonged to America. But China wasn't just trying to match NASA's achievements. They were attempting something far more ambitious, to answer the most profound question in science in a single mission: are we alone in the universe? The spacecraft carried a poetic name that captured the magnitude of this quest, Tianwen 1, meaning questions to heaven. Inside its protective shell sat 3 components that would soon rewrite textbooks: an orbiter to map Mars from space, a lander to touch down safely, and most importantly, a 240-kilogram rover named Zhurong, after the Chinese god of fire. This wasn't just a rover. It was humanity's most sophisticated alien detective, equipped with 13 different scientific instruments designed to solve a 4-billion-year-old mystery. After a death-defying 220-day journey through the cosmic void, Tianwen 1 reached Mars on February 10, 2021. For 3 agonizing months, mission controllers prepared for the most dangerous part of the mission, the landing. Mars is littered with the wreckage of failed missions. The planet's thin atmosphere creates what engineers call the 7 minutes of terror. Just enough air to burn up a spacecraft, but not enough to slow it down safely. Russia lost 9 missions to Mars. NASA has seen billion-dollar projects turn to scrap metal in seconds. But on May 14, 2021, China achieved the impossible. The lander touched down perfectly in Utopia Planitia, the largest impact basin in the solar system, a depression so vast it could swallow the entire continental United States. 7 days later, Zhurong rolled off its landing platform and began humanity's most important treasure hunt. The location China chose for this mission wasn't random. Utopia Planitia had been taunting scientists since the 1970s, when NASA's Viking landers first touched down there. The region looked suspicious, too flat, too uniform, too much like something that had been shaped by flowing water. But it was a 2016 NASA discovery that made Utopia Planitia irresistible. Buried beneath this seemingly barren plain was a deposit of water ice, so massive it defied belief. We're talking about 12,100 cubic kilometers of frozen water, enough to fill Lake Superior, one of the largest freshwater bodies on Earth. The question was, how did all that water get there? Zhurong was designed to find out. Among its arsenal of scientific instruments, one would prove to be revolutionary: ground-penetrating radar that could see up to 100 meters below the Martian surface. This technology works like geological X-ray vision, sending radio waves deep into the ground and analyzing what bounces back. When the waves hit different types of rock, sediment, or ice, they create distinct signatures, like fingerprints left behind by ancient geological processes. It's the same technology that archaeologists use to find lost cities, that helped locate Richard III's remains under a parking lot in England. But on Mars, it was about to uncover evidence of something far more spectacular than buried kings or forgotten civilizations. As Zhurong began its systematic survey of the alien landscape, its radar started painting a picture that would soon leave the global scientific community speechless. Day after day, Zhurong methodically crawled across the Martian surface, its radar probing deep into the planet's hidden history. The rover was designed to operate for just 93 Earth days, but the mission was so successful that it continued working for an incredible 358 days, nearly 4 times its planned lifespan. And then, buried in the terabytes of data streaming back to Earth, mission scientists spotted something that made them stop everything they were doing. The radar had detected 76 distinct geological structures buried 10 to 35 meters below the surface. But this wasn't just random rock formation. These structures all sloped in the same direction, at angles between 6 and 20 degrees, across a 1.3 kilometer stretch of terrain. To understand why this discovery was so revolutionary, you need to understand how coastlines work. On Earth, when waves crash against a shore day after day, year after year, they create distinct patterns in the sediment. Fine particles get sorted and deposited in sloping layers that record the long-term balance between water level, wave energy, and sediment supply. These geological fingerprints can survive for millions of years, buried and preserved like pages in a stone book. What Zhurong had found looked exactly like these buried beach deposits. The team was so excited, they immediately began comparing their Martian discovery to similar formations on Earth. They found a perfect match in the Bay of Bengal, where ancient coastlines have been buried and preserved in almost identical patterns. But could they be sure? Could there be other explanations for these mysterious sloping structures? The researchers systematically ruled out every alternative. Sand dunes would create slopes pointing in multiple directions as winds shifted over time. Lava flows would follow the path of least resistance, creating chaotic patterns. Landslides would leave irregular, jumbled deposits. But the Zhurong data showed something completely different. 76 structures, all sloping the same way, all at consistent angles, all perfectly preserved in a 1.3 kilometer stretch that pointed directly toward the lowlands of Utopia Planitia. There was only one plausible explanation. These were the fossilized remains of an ancient Martian shoreline. The implications of this discovery are staggering. If Mars once had stable coastlines, it means the planet maintained liquid water for extended periods, possibly millions of years. And coastlines aren't just pretty scenery, they're biological hotspots, the places where life is most likely to emerge and thrive. Shoreline environments offer everything that early life needs to get started. They concentrate organic molecules through evaporation, promote the formation of complex chemicals like RNA and proteins, and provide energy sources like UV radiation and chemical gradients that can drive the reactions necessary for life to begin. Rivers, by contrast, are terrible places for life to start. They're too dynamic, constantly flushing materials downstream before complex molecules can accumulate and react. If you're looking for the birthplace of Martian life, ancient coastlines are your best bet. But this discovery does more than just point us toward promising locations to search for alien fossils. It fundamentally challenges our understanding of Mars's climate history and forces us to confront one of the most perplexing puzzles in planetary science, the faint young sun paradox. 3.5 billion years ago, our sun was about 25% dimmer than it is today, too faint to keep Mars above freezing. And yet the geological evidence suggests that ancient Mars was covered with rivers, lakes, and oceans. If the heat didn't come from the sun, where did it come from? Scientists have proposed 3 possible solutions to this paradox, and none of them are entirely satisfactory. The first theory suggests that Mars was warm and wet, with a thick atmosphere loaded with greenhouse gases that trapped enough heat to keep water liquid for millions of years. But our climate models suggest that carbon dioxide and water vapor alone can't produce the warming needed. You'd need other gases like methane or ammonia, which are unstable and hard to maintain long term. The second theory proposes that Mars was only warm and wet intermittently, mainly during major volcanic eruptions or asteroid impacts that released massive amounts of heat or greenhouse gases. But we can't be sure if these warm spells happened frequently enough or lasted long enough to explain all the evidence for flowing water. The third theory suggests that Mars spent most of its history as a frozen world, but periodic changes in the planet's orbit or sudden heating events melted the ice and created temporary rivers and lakes. This explains both the evidence for glacial activity and flowing water, but it's unclear what could have melted the ice so regularly. None of these scenarios perfectly explains Mars's complex climate history. The Zhurong discovery adds crucial new data to this puzzle, but it also raises even more questions. The discovery has triggered a new space race, but this time, it's not about national prestige. It's about answering the most important question in science: are we alone? NASA had been planning a Mars sample return mission for 2027 or 2028, with samples arriving back on Earth in the early 2030s. This mission would have given us definitive answers about Mars's ancient environment and whether it ever supported life. But budget cuts and technical challenges have pushed the mission back to 2040, and recent proposals threaten to cancel it entirely. Even as scientists celebrate the Zhurong discovery, new mysteries are emerging that make the picture even more complex. We know Mars had water 4.45 billion years ago. Evidence from Martian meteorites proves that hot, water-rich fluids existed on the planet almost from its birth. We know it had rivers and lakes, polar ice caps covering an area similar to the United States, and now, thanks to China, we know it had ocean coastlines. But what happened to all that water? Some of it is still there, locked in polar ice and underground deposits. Some of it escaped to space when Mars lost its magnetic field and protective atmosphere. But the timeline is murky, and the mechanisms are still debated. We also don't know how long Mars's oceans persisted. Were they permanent features that lasted for hundreds of millions of years, or temporary phenomena that appeared and disappeared as the climate fluctuated? The answer matters enormously for assessing Mars's potential for life. If the oceans were permanent, Mars could have supported complex ecosystems for geological ages, enough time for life to evolve from simple microbes into something more sophisticated. If they were temporary, we might be looking at brief windows of habitability punctuated by long periods of frozen sterility. The Zhurong discovery provides compelling evidence for at least one stable coastline, but it represents just one location during one period of Martian history. We need more data from more locations and different time periods to understand the full story. If Mars did have stable oceans and coastlines, the next question is obvious. Did life take advantage of these conditions? And if it did, could evidence of that life still exist today? This is where the story becomes even more exciting. Unlike Earth, where plate tectonics and erosion constantly recycle the surface, Mars is geologically quiet. Features that are billions of years old can be preserved almost unchanged, like photographs in stone. If life existed in Mars's ancient oceans, it might have left behind biosignatures, chemical fingerprints that could still be detected today. These might include specific minerals that only form in the presence of biological activity, organic molecules that could be remnants of ancient cells, or even microscopic fossils. The most promising places to look for these biosignatures are exactly where Zhurong made its discovery, in the sedimentary deposits that once formed ancient coastlines. These environments would have been ideal for preserving biological material, protecting it from the harsh radiation and chemical processes that would destroy evidence elsewhere on the planet. Some scientists believe that if Martian life ever existed, it might still exist today in underground refuges where liquid water persists. The massive ice deposits discovered beneath Utopia Planitia could potentially harbor microbial communities, surviving in the deep subsurface just as they do in Earth's most extreme environments. The Zhurong mission represents more than just a scientific breakthrough. It's a technological triumph that has reshaped the global space landscape. When Zhurong successfully deployed on Mars, China became only the second nation in history to achieve this feat, breaking America's monopoly on Mars surface operations. But the mission's success goes beyond national achievement. It demonstrates that the tools and techniques needed to explore Mars are becoming more accessible, opening the door for more nations and organizations to participate in planetary exploration. The rover's ground-penetrating radar, which made the crucial discovery, represents a new generation of subsurface exploration tools that could revolutionize how we study planets. Similar instruments could be used to explore the subsurface of the Moon, Europa, Enceladus, and other worlds where liquid water might exist beneath protective ice shells. The mission also showcased China's growing capabilities in autonomous spacecraft operations. Managing a rover on Mars requires split-second decision-making during critical phases like landing, but it also demands sophisticated autonomous navigation systems that can operate for months with minimal human intervention. Mars is so far from Earth that radio signals take between 4 and 24 minutes to travel one way, depending on the planet's positions. This means that real-time control is impossible. Rovers must be smart enough to navigate obstacles, make scientific observations, and even protect themselves from hazards without waiting for instructions from Earth. Zhurong excelled at all these challenges, operating for nearly 4 times its planned lifespan and making discoveries that no one anticipated when the mission was designed. The Zhurong rover's discovery has jolted the global Mars exploration community into action. Its evidence for ancient shorelines is not just another scientific data point, it's a revelation that could change how we see Mars and ourselves. NASA's Perseverance rover continues its hunt for signs of ancient life in Jezero crater, while the European Space Agency pushes forward with ExoMars, aiming to drill deeper than ever into Martian rock. But China has made the boldest moves, building on the success of Tianwen 1 and Zhurong. Beijing is planning Tianwen 3, a sample return mission as early as 2028, and even more ambitiously, a crewed Mars mission by 2033. If successful, this would leapfrog NASA and mark the first human footprint on another planet. Yet Zhurong's discovery goes beyond geopolitics. By sharing data internationally, China has fostered surprising collaboration, uniting scientists across borders to decode what Mars's coastlines mean. The questions now reach far deeper than national pride. If Mars once had oceans, then life may have had a chance. And if life could arise on both Earth and Mars, it suggests the universe might be rich with living worlds. But there's a warning here too. Mars lost its oceans, atmosphere, and habitability. Studying that collapse may hold urgent lessons for Earth's own fragile climate. Still, enormous mysteries remain. How long did Mars's oceans last? Was its atmosphere thick and stable, or fleeting and fragile? Was the loss gradual or catastrophic? And the greatest question of all, did life ever truly take hold in those Martian seas? Zhurong has given us the strongest evidence yet that Mars was once a blue world, but more importantly, it has proven that planetary exploration is no longer dominated by one nation. A new space race has begun, one driven as much by collaboration as by competition, and one that will shape the first steps of human expansion beyond Earth. The story of Mars is no longer just about the past, it's about our future. One day soon, human explorers may stand on those ancient shores, searching not only for signs of Martian life, but for answers to how we might sustain our own.